Here's a statistic that should reframe how you think about AI risk. Study after study of AI failures points to the same origin. The majority of the damage traces back not to how the model was built, but to how poorly the problem was understood before anyone started building. Wrong objective, wrong context, wrong assumption about who'd be affected. The model then executed that misunderstanding flawlessly. So let me ask you something. In your organization, how much effort goes into understanding an AI problem before someone starts training a model? Honestly, usually a kickoff meeting and a rough brief, and then months of engineering built on top of a foundation nobody examined. That's exactly the gap the map function exists to close. Map is where you establish context, understand the system in its full setting, identify stakeholders, discover risks, and reach an honest go or no go decision, all before you're committed. In this chapter, you learn the purpose of map and why it comes before measurement, how to establish business and technical context, how to do stakeholder analysis that includes the people who never asked to be affected, how to build and maintain a risk register and an AI inventory, and the most underused idea in the whole framework, the go or no go decision point, where sometimes the right answer is don't build this at all. Let's learn to look before we leap. So what is MAP actually for? In one line, MAP is about establishing the context needed to understand and identify risks. Context first, then risks emerge from it. Let me explain why that ordering is so important because it's easy to skip. Imagine someone hands you a model and asks, "Is this risky?" You genuinely cannot answer. Risky doing what? For whom? In what setting? A model recommending films and a model recommending cancer treatments could be technically identical and could not be more different in risk. The risk isn't in the model, it's in the context the model operates in. So MAP is where you build that context deliberately before you assess anything. And NIST frames MAP as enhancing the ability to understand contexts, which is a lovely way to put it because it's about seeing clearly. Here's a real consequence of skipping it. I worked with a team who'd built a genuinely clever model, technically excellent, and in MAP, if they'd done it, they'd have discovered the data they trained on came from a population quite different from the one they'd deployed to. The model was brilliant, and brilliant for the wrong people. That's a MAP failure, not a modeling failure. So the purpose of MAP is to earn the right to build by first understanding what you're building, for whom, and in what world it'll live. Skip it, and everything downstream is built on sand. So establishing context has two halves, and you need both. Let's take them in turn. Business context first. And the deceptively hard question here is, what problem are we actually solving? Not what do we want to build, what problem? Those are different, and teams conflate them constantly. Let me give you an example. A client told me they wanted a chatbot to reduce support costs. That's a solution, not a problem. So I asked, what's the actual problem? Turned out, customers couldn't find answers to simple questions and were calling unnecessarily. Once we framed it that way, the best solution wasn't a chatbot at all. It was fixing their help pages. They'd nearly built an expensive AI system to patch a content problem. Business context also means defining what success looks like in measurable terms and what the constraints are. Budget, timeline, risk appetite, regulation. Then technical context. What data do we have and is it any good? What are the technical constraints? Where will this run and what does it integrate with? What's the fallback when it's unavailable? And here's the point people miss. These two halves have to talk to each other. Business context set without technical reality gives you impossible promises. Technical work without business context gives you a beautiful solution to no real problem. So MAP holds both in the same room. That conversation is the work. So let's talk about stakeholders, and I want to push you past the usual comfortable version of this. The comfortable version lists the people in the building. The project sponsor, the users, the technical team, maybe legal. Fine, necessary, incomplete. Here's who gets left off, and it's always the same group: the affected individuals. The people your system makes decisions about, who never ask to be involved, who often don't even know the system exists. The loan applicant, the job candidate, the patient. They're the ones who bear the harm, and they're the ones with no seat at the table. So, how do you include people who aren't in the room and can't be? You represent them deliberately. You assign someone to advocate for them. You ask, for every design decision, how does this land for the person on the receiving end? Sometimes you actually go and talk to representatives of that group, which is rare and enormously valuable. Let me give you a real one: a team building a benefits eligibility model. Every stakeholder in the room was an administrator focused on fraud reduction. Nobody represented the claimant, the person who'd be wrongly flagged and spend months proving a negative. Add that voice, and the whole risk picture changes. So here's the discipline for your stakeholder analysis. After you've listed everyone in the building, ask who's affected, who isn't here, and then make sure someone speaks for them. That question alone catches an enormous amount of downstream harm. So we covered legal compliance at the governance level. Now we apply it to a specific system in MAP, which is where it gets concrete. At the governance level, you establish that someone tracks the law. Here in MAP, for this particular system, you ask the pointed question: which laws actually apply to this system given what it does and who it affects? And that depends entirely on the specifics. A model that touches health data pulls in one set of rules. A model making credit decisions pulls in another. A model affecting employment, another. A model processing data of people in different jurisdictions pulls in all of theirs at once. Same organization, different systems, completely different legal footprints. So the map task is to work out this system's specific footprint. Where does the data come from and whose laws follow it? What kind of decision is this and what protections attach to that decision? Who's affected and what rights do they have? And here's the point I keep returning to because it keeps being ignored. Existing law applies now. You're not just scanning for AI-specific regulation. Anti-discrimination law, consumer protection, data protection, they already bind this system today. The team that waits for AI law while breaching current law is exposed right now. So the practical output of this step is a clear picture per system of the legal terrain it operates in. Because you cannot manage a compliance risk you never mapped, and you certainly can't measure it. So now we get to the core of MAP, actually finding the risks. And the key word here is systematic, because the alternative is what most people do, which is guess based on what they happen to worry about. Here's the problem with guessing. You find the risks you're already primed to see. A security person finds security risks. A lawyer finds legal risks. And the risk nobody's primed for, the one outside everyone's expertise, sails straight through. That's usually the one that hurts you. So how do you do it systematically? You use structure to force completeness. Remember the harms framework from chapter 4? Use it as a checklist. Walk every level. Individual harms, have we considered them? Organizational, societal, environmental. Walk every trustworthy characteristic. Could this be invalid, unsafe, insecure, unfair, opaque, privacy invading? Each one is a prompt that surfaces risks your instinct would skip. And you walk the life cycle too. What could go wrong in the data, in training, in deployment, in operation, in decommissioning? Then you categorize what you find so you can prioritize later. By type, by level, by severity, by reversibility. Let me give you a practical tip from doing this many times. Do it with a diverse group in the room: the security person, the lawyer, the operator, the business owner, and if you can, someone who represents the affected. Each sees a different slice. The magic of a good risk workshop is that someone says something another person would never have thought of. So systematic beats intuitive. Structure catches what instinct misses. So you've discovered your risks. Now, how do you stop that hard work from evaporating? Because here's what usually happens: you hold a great risk workshop, sticky notes everywhere, real insight, and 3 weeks later, it's a photo on someone's phone that nobody looks at again. The risk register is how you make risk discovery durable. It's the living record of what you found and what you're doing about it. So, what's in it? For each risk, a clear description of what could actually go wrong, not a vague category. An assessment of how bad and how likely. Who owns it? A named person. What you're doing about it, and its current status. But here's the word that matters most: maintaining. A risk register is not a document you produce once and file. It's alive. New risks appear as the system evolves. Existing risks change as the context shifts. A risk you rated low last year might be high now because the regulation changed or the usage grew. I've seen so many risk registers that were genuinely excellent on the day they were written and then frozen. 18 months later, they describe a system that no longer exists, assessing risks that have moved. A frozen register is worse than none because it gives false comfort. So the discipline is a rhythm. The register gets reviewed on a schedule and gets updated whenever the system or its context changes. Assign someone to own that rhythm. Otherwise, it dies quietly and you won't notice until something you'd stop tracking goes wrong. So here's a question that embarrasses more organizations than you'd think. How many AI systems do you have? And I mean an exact number. I've asked this in boardrooms and watched people realize they have no idea. I mentioned the client who honestly answered somewhere between 12 and 200. That's not incompetence. It's because AI enters through a dozen doors. Bought-in tools, vendor features switched on, models built in a corner by an enthusiast. AP is called from a script. Nobody's keeping a list. And here's the iron rule: you cannot govern what you cannot see. Every system not on your inventory is a system with zero governance by definition. So the inventory isn't admin. It's the precondition for everything else in the framework. It's genuinely the first practical thing I'd have most organizations do. So what's in it? Every AI system, what it does, who owns it, what data it uses, what decisions it makes, and its risk level. That last one lets you focus your effort where it matters. Then, data flow mapping, which goes deeper. For each system, where does the data come from? Where does it go? Who touches it along the way? This matters enormously for privacy, for security, and for understanding blast radius when something goes wrong. Here's the honest part. Building the first inventory is hard, tedious work. Discovery always is. But it's the single highest value thing a new AI governance function can do, because everything else depends on knowing what exists. So if you do one thing after this chapter, start the list. So beyond knowing what systems you have, you need to understand how they connect and what you truly depend on. Because risk doesn't respect boundaries, it flows along connections. Let me show you why this matters with a chain. Your AI system depends on data, which comes from a source, which might be a third party. It depends on infrastructure, maybe a cloud provider. It depends on a model, perhaps from a vendor. It depends on other systems that consume its output and act on it. Pull any link in that chain and things break, sometimes in places you never connected to the original failure. So dependency mapping is tracing those connections. What does this system rely on to work? And just as important, what relies on this system? Because that second one tells you the blast radius. If this model produces a bad output, what downstream processes consume it and act on it before a human ever sees it? Then critical asset identification. Among all this, what genuinely can't fail? Where would a failure be catastrophic rather than merely annoying? That's where you concentrate your resilience, your monitoring, your redundancy. Here's a real example of why this bites. A team relied on an external data feed for their model. The feed changed its format one day without notice. The model kept running, silently producing nonsense because nobody had mapped that dependency as critical or monitored it. A small upstream change, a large downstream mess. So the question, for each important system, what would have to fail upstream for it to fail? And who's watching those things? So we reach what I think is the single most underused idea in the entire framework, the go or no go decision. The moment where you genuinely ask, having understood all this, should we build it at all? And here's why it's underused. By the time you've done all this map work, there's momentum. People have invested time. Someone's promised something to a stakeholder. Budgets are allocated. And so no go feels like failure, like admitting the whole thing was a waste. Let me reframe that completely. A well-informed no-go is not a failure. It's one of the most valuable outcomes governance can produce. Deciding not to build something that would have caused harm, or wouldn't have worked, or wasn't worth the risk, that's a win. You just saved money, reputation, and possibly real people from harm. So what does an honest go or no-go look like? You put the full picture on the table. Here's what it does, here's who it affects, here's what could go wrong, here's what we can and can't mitigate. And then you ask honestly, do the benefits justify the risks we can't remove? Not the risks we've mitigated, the residual ones. And crucially, no-go isn't the only alternative to go. There's go with conditions. Proceed, but only with these safeguards, this monitoring, this human oversight, this limited scope to start. Here's the culture point that makes or breaks this. If your organization treats every no-go as a failure, you'll never get an honest one. People will force projects through to avoid looking like they wasted effort. So you have to make no-go a respectable, even praised outcome. So ask yourself, when did your organization last say no to an AI project on purpose after understanding it? If the answer is never, your go or no-go isn't real. It's just a go with extra steps. So let's gather up the map function. First and foundationally, understanding comes before action. Most AI failures trace to poor problem understanding, not poor engineering. Map is where you earn the right to build. Second, solve the problem, not the solution. Teams jump to what they want to build and skip what problem they're actually solving. Sometimes the answer isn't AI at all. Third, include the people who aren't in the room. After you've listed everyone in the building, ask who's affected who isn't here and make someone speak for them. Fourth, you cannot govern what you cannot see. The AI inventory is the highest value first step for any governance function. Start the list. Fifth, map dependencies both ways. What you rely on and what relies on you. The second tells you blast radius. And sixth, the go or no-go is real only if no-go is a respectable outcome. A well-informed no is a win, not a failure. If you want a detailed, structured course on this topic with role plays, quizzes, and practice tests, our Udemy course link is in the description. Do subscribe to the channel if this is landing for you. And the playlist link is in the description, giving you every video in the series in order. Next, we move to measure, where we learn to test what we've mapped. See you there.